In this example, we're going to graph the equation y is equal to 2x squared take 8x plus 3. This is a quadratic equation because we've got a power of 2 here. And it will give a parabola-shaped curve. Now we can compare it to our general standard form of the quadratic equation, y is equal to ax squared plus bx plus c. Now if the quadratic equation is in that form, we straight away know that this value here, the constant term, is the y-axis intercept. So straight away we can say the y-axis intercept is at y is equal to 3, or as a coordinate point we could write that as 0, 3. And we can go and plot that straight away on our graph. And there it is there at 0, 3, that will be our y-axis intercept. Now we can also quite easily find the line of symmetry. To find the line of symmetry from a quadratic equation in standard form, we just use the rule x is equal to negative b over 2a, and we can substitute the values of a and b into this little rule to come up with our equation. So doing that, we'll get x is equal to the negative, and I like to do my substitution with brackets. The b value in this case is negative 8, so important that you include the negative here. So it's the negative of negative 8 divided by 2 times the a value, which is 2. Okay, so working that out, we get the negative of negative 8 is positive 8 over 2 times 2 is 4. And we get our line of symmetry is equal to x is equal to 2. And this is in fact the equation of the line of symmetry, x equals 2. And on our graph, we can actually plot that as a vertical line, x is equal to 2. And that's the line that the parabola-shaped curve will be symmetrical about. Now the other thing we know about this line of symmetry, it will actually be the line on which the turning point lies. So it gives us the x-coordinate of our turning point, x is equal to 2. So then to find our turning point, we also need the y-coordinate of the turning point. We've already got the x-coordinate. To find that y-coordinate, we just substitute that x is equal to 2 back into our original equation. So our original equation was y is equal to 2x squared take 8x plus 3. We're going to substitute that x is equal to 2. Again, I like to use brackets to show my substitution. Take 8 times 2 plus 3. We can work that out either mentally or on a calculator. So 2 squared is 4, 2 times 4 is 8. Take away 8 times 2, or take 16 plus 3. And that'll come out to 8 take 16 is negative 8. Negative 8 plus 3 is negative 5. So our turning point as a coordinate point would be x value of 2, y value of negative 5. So now that we've got that turning point, we can go and plot that on our graph as well. So on our graph here we can see that our turning point will be at x is equal to 2, and our y value of the turning point was at negative 5 right at this point here. And because we do have symmetry with our parabola curve, we actually have a third point. So where this y-axis intercept is, the same distance across on the other side of the line of symmetry will give a third point. And we can now go ahead and sketch our nice smooth parabola-shaped curve. Like so. It takes a bit of practice getting the shape of a parabola right. Put some arrows on the end. And we can now say that that's the curve of y is equal to, or the graph of y is equal to 2x squared, take 8x plus 3.